Hey YouTube, welcome back. Today we continue our series in system design fundamentals. Today we have today we'll talk about database replication. In the previous video, we talked about the load balancing and how the load balancing solve the issue of the availability, and also solve the issue of uh, of uh, of if one server go down by distributed all the requests to multiple servers. So we make sure that the user will take a response no matter what. And we said that in current server, in the current design, we have only one database. We don't have more than one database, and we wanna like fix that. And we fix that by using something. Let me just copy this design because I'm using here. So let's just also copy this title, please. Yeah. Yeah. Okay. So we talk about database replication. Database replication. So now the web tier looks good. Okay, we have load balancer, we have multiple servers. What about the data tier? This one. Okay, the current design has one database, and so it does not support failover and redundancy. If this database failed, our data is gone. So we use something called database replication. It is a common technique to address those problems. So let's just take a look. So let's just first take a code from Wikipedia. So database replications can be used in many database management system, usually with a slave-master relationship between the original, which is the master, and the copies of this master that are called slaves. So a master, let's just try to delete this one. Let's just try to delete all of that. Let's see how the master actually slave looks like, and after that let's just start to discuss about how they work. So let's say that we have this database, okay, and let's just make this one. I want to make it like you know what no, delete. Sorry, let's just delete this one, and let's just copy this one. Yeah, that would be way more better and way more easier to draw. So let's call this one. This will be master database DB. Okay, and let's just make it with bold, and I want to make it with different color, because usually database have has like this gold color or green color. And let's just make the border also green. Yeah, so we know this is a database. So we have a master database, okay, and we have two sleeves. Let's just delete those and copy this one. And this one, this slave 1 dB, and we have slave 2 dB. 2 dB. And a master database generally only supports the write operation. So this one only supports the write operation. So if this server has a write operation, we'll send it here. And also if this one have a write operation, it will send it here. Let's just make it I don't like this this rows looks quite ugly, I'll be honest. Can we make it like that? Yeah, it looks quite better right now. Yeah, so these supports write operations. So let's just make it, this is a write, and oh, this is too small. And let's make it bigger. Yeah, and this is also write operation. So the master only supports the write operation, and the sleeves gets sleeve database gets copies of the data from the master database and only supports the read operations. So the master will give the sleeve the copies, okay, and also the slave only supports the read operations. So the read operation, that if the server wanna read something, it will access the slave. Okay, let me just, so this one is read operation. Let's make it was small, and this one also is read operation. So if you can see here from this design, basically, sorry, wait a minute, yeah. So basically here the sleeve database get the copies from the master database, okay, and only supports the read operation. So all database modifications commands like insert, delete, or update must be sent to master database. Most replication requires a much higher ratio of read to writes. Most applications requires that. So we have thus the number of slave databases in the system is usually larger than the number of master databases. Okay. So and this one shows what's happening. So let's just talk on advantages of database replication. So it has first better performance in the master slave model. All writes and updates happen in master nodes, whereas read operations are distributed across the slaves nodes. So if you have more slave, we can add the third one slave, but just it will be, the design will look quite awful. So this model improved performance because it allows more queries to be processed in parallel. So instead of having one database that works with the queries, we have two databases right now works with the queries specifically in the rate ratio. We have something called it's also reliable. So if one of your database servers is destroyed by a natural disaster such as earthquake or something like that, data still preserved. You do not need to worry about data lost because data is replicated across locations, because each database has its own location here. Because the database is a server, so the server has a location. You put it in a specific place. So in the previous section, we discussed how the load balancer helped and improved the availability. We talked about that in the previous video. And we ask the same question here. What if one of the databases goes offline? So if only one slave database goes offline, so let's just assume that this one goes offline. Read operations will be directed to the master database temporarily. So let's see that both of them are go offline. So all read operations will go to the master directly for now. Okay. As soon as the issue is found, a new slave database will replace the old one. In case multiple slave databases are available, read operations are redirected to other healthy slave database. So a new database server will replace the old one. So this one, when the slave goes down, if the master goes down, if this master goes down, a slave database will be promoted to be the new master. So this one, let's just do it. Promote this one to be the master, and all database operations will be temporarily executed on the new master database. A new slave database will be replace the old one for data replications immediately. In production systems, promoting a new master is more complicated, as the data is in a slave database might not be up to date. So the missing data needs to be updated by running data recovery scripts, for example. So although some other replications methods like multi-masters and circular replications could help. Those are not in those beyond our this video's content, because we talk about the fundamentals. We don't want to take deep into it. So the current design works as follow. User user gets the IP address of the load balancer from the DNS. Okay, a user connects with the load balancer with the IP address. The HTTP request is routed to either server, this server 1 or server 2. Let's just call them server 1 and server 2. Server 1 and server 2. The web server reads users. The web server reads users' data from the data slave, and a web server routes any data modifications operations to the master database, and this includes write, update, and delete operations. So now we have a solid understanding of the web and the data tier. It is time to improve the load response time, and this can be done by adding something called a cache layer, and shifting the static content like JavaScript, CSS, image, video to something called a content delivery network. And these things we will talk about them in the next videos. In the next video we'll talk about the cache. After that we talk about the CDN and why we need the CDN. And yeah, that's it for today's video. And I hope my content was I hope my description is quite good for you. If you like my content, make sure to subscribe and hit the notification bell so you will never miss a video. And see you in future problems.